everyone, in this video we are going to discuss the trial paper for Negeri Sembilan. Alright, let's start with number 1. Given that 5p plus 3q, p and 5p minus 3q are three consecutive terms of a geometric progression, so express q in terms of p. Okay, so in this kind of question, we know that since it's given to us that it's a geometric progression, so we know that for a GP, right, they have something in common, which what we call as common ratio, which means when you try to use your second term to divide by your first term, you will get the exactly same thing when you use the third term to divide by your second term. Okay, this is because of when you try to divide the subsequent term with the previous term, you are actually finding their ratio. And because it's a GP, their ratio should be the same. Okay, so now we just substitute the information that given in this question. So T2 is P, T1, the first term is 5p plus 3q, and then T3, the third term is 5p minus 3q. So divide by second term is going to be p. Okay, so after that, we're just going to arrange the expression until we get an expression q in terms of p. Okay, so we just continue to do the cross multiplication. Okay, so you'll be able to get 25p squared minus 15pq plus 15pq and end with negative 9q squared. Okay, so you just arrange it and try to solve accordingly. So I'll be able to get 24p squared equal to 9q squared. Okay, so basically here you will get 0. Then after that, I'm just moving the q in front and I move the p to the back so that I do not have any negative term. Okay, so in this case, then I will need an expression in terms of p, right? So which means I'll need to move the 9 to the other side. So I'll get q squared equal to 24 over 9 p squared. Okay, so this is the term that actually you can simplify. But when you try to check here, right, you see that later you are going to move the square and to the other side and it will become a square root. So 9 is something that can be solved by a square root. So what we try to do here is we don't simplify them in the simplest form first. Okay, so next one, q will be equal to, so square root 24 over 9 p squared. Okay, so we know that as we try to put square root, it actually means that it's a square root for everything. Yeah, so this is what you can try to understand from. Okay, so for 24, we try to simplify it. So it's going to be 4 times 6 because we want to put it in a simplified set. So divide by 3. Okay, square root 9, I will get 3. Then square root p squared, I'm going to get p. Okay, so from here, square root 4 is given me 2, and then 6 is something that cannot solve by using the square root. So I'll just leave the answer. So divide by 3 and then p. Okay, so if you want to write it like nicely, which means you can just leave your answer like 2 square root 3p divided by 3, and that's the end of this question. Okay, so the marks will be actually given for the first one. Then after that, it's going to be like your own calculation, right? Then after that, the last one. So meaning 1 mark and 2 mark. So for the full mark, 2 marks here. Okay, so let's move on to the next one. Okay, number 2, given that both quadratic equation x squared plus px plus q equals to 0 and 2x squared minus kx plus h equals to 0 have two equal roots, so you need to express h plus q in terms of p and k. Okay, so which means that actually you can see that for the first quadratic equation here, right, you have the term of p and q, and for the second one you have k and h here. So which means that later what are we trying to do is for the first one, we will try to get the expression where q equals to what. Then after that, for the second equation, we are going to get like h equals to what. So after that, we can make an expression like h plus q together. Okay, so since that is given that both of these equations have two equal roots, right? So we know that for two equal roots, so what does that mean? Yeah, so for as long as you see the words right, like two equal roots, two distinct roots, or have no real roots, then you should be able to relate to the concept of the discriminant, which is b squared minus 4ac. Okay, so in this case, it's going to be equal root, so that's why it's equal to 0. Okay, so we are going to form two different expressions. So let's start with the first one. So x squared plus px plus q equals to 0. So since it's already arranged in a general form of quadratic equation, so we can just substitute. So b squared minus 4ac equals to 0. So the b is the p, so minus 4, and A is 1 and C is Q, so equals to 0. So from here, I'll be able to get like 4Q will be equal to P squared. Okay, so imagine I'm just like bringing this to the back, then after that, I'm writing like 4P in front, then P squared at the other side. Okay, so from here, then I'll be able to get Q equal to P squared over 4. Alright, so this is like my first expression that I get. Okay, then after that, move on to the second one. So I will have 2x squared minus kx plus h equals to 0. So same thing, because this equation have two equal roots as well. So that's why b squared minus 4ac will be equal to 0. And this is how I get negative k squared. So make sure that every time when you substitute your BAC, make sure it's arranged in the general form, right? Okay, which means like ax squared plus bx plus c equals to 0. So after that, ends with h equals to 0. Okay, so let's simplify it. So we will have k squared equal to 8h. Okay, so since we want h plus q, right? So the same thing, we try to make the h as our subject here. So h will be equal to k squared divided by 8. So this is our second expression. Okay, sorry, second equation. So now we need to express our h and q in terms of p and k, right? So what we try to do, so since we have the first one, which is q, then the second one is h. So what we try to do here is just plus them together. Okay, so h plus q will be equal to, so for the h part is going to be k squared divided by 8, and then plus q is p squared divided by 4. Okay, so after that we are just going to combine them together. So this one you need to multiply 2, this one multiply by 2, right? So that we can combine them, because in addition for fraction, you need to make the denominator the same. So over 8, then k squared plus 2p squared. So this should be your last answer. Okay, alright, so for this question, it's a 3 marks question. So which means that you will have 1 mark for your answer. Then after that, the first mark is given for the application for the discriminant part, which you need to substitute your value then equals to 0, which means either here or here is going to give you, here is going to give you 1 mark. Then after that, here and here, either one is going to give you 1 mark. So which means like 1, 1, 2, so which give you 3. Yeah. So this one is like either lah. So which means that if let's say you got the first one but you didn't got the second one correct, then you also have the first one. So if you didn't get your H correct, then you get your Q correct, then you also have 1 mark, because it's like all in the scheme. Okay, so let's move on to number 3. Okay, so number 3, this is a diagram with a part of the curve with the equation given here and the straight line PQ. Okay, so PQ, the line PQ is actually the tangent for the curve at point P. Okay, so the question wants you to find the value of K. Alright, so don't worry if you realize that like my questions, the arrangement here is slightly different than the paper that you have. Yeah, because I just want to make everything fit into my screen, so it's easier for my explanation and so on. But yeah, it's basically the same thing. Okay, so we need to find the value of K, which is the x coordinate of the point P here. Okay, So what do we need to do? So as you can see here, we have the curve and we have the tangent. So by having this information, then you should be able to relate to the chapter for differentiation. Okay, so which means that we need to find our derivative form, which means we try to get the dy dx here. Then the dy dx is also mean the gradient for the tangent, right? Then after that, from this straight line, then we also try to find out what is the gradient. Then after that, we try to do comparison there. Okay, so perhaps we can start with finding the gradient first by using the straight line given. So we have for the line PQ, which is the tangent, they are having the equation of y equals to h minus x. So we're just going to arrange it slightly. So negative x plus h. So from here, then I'll be able to get the gradient for the tangent, right? Because PQ is the tangent. So the gradient for the tangent is going to be -1 because y equals to mx plus c and my m is -1. Okay, so from there, then I can continue with it. So I have my curve here, right? So which means that after I substitute k in my dy dx, which means in my gradient function, and I will be able to get the gradient for tangent, which is -1. So what I need to do next is to find the derivative form, or in another words, I need to find the gradient function. So it's given that y equal to 4 over x plus 3 square. Okay, so if you are familiar with this form, then you can straight away do the differentiation. But yeah, I'm just afraid that maybe some of you are not used to it. So we're just going to change it to composite. Then after that, we do it step by step. Okay, so for the y here, then I have 4. Then after that, this part is going to be x plus 3, then power -2. Okay, so after we change to composite, then we can start to do the differentiation. Power, bring it forward, then multiply. So I'll get -8. Okay, then after that, copy whatever that is inside the bracket. So x plus 3, power -1, so -3. And don't forget, you need to differentiate what is inside your bracket. So which here, after you differentiate, you are just getting 1. Okay, which is no matter whether you write it or not, it doesn't make much difference in this question. So after that, we are just going to rearrange it. So -8, then after that, put it back to a fraction form. Okay, so this is what we get for dy dx. I'm sorry, I should actually write here. Okay, so this is my dy dx. All right. So since we know that dy dx, after we substitute the x, is eventually going to be equal to the gradient of the tangent at that specific point. So since we have the gradient for the tangent is -1, right? So which means that our dy dx will be equal to -1 when my x is equal to k. Okay, which is like at this point because the tangent is happen at this point. So now I'm just going to substitute it. So when x equals to k, so I'm just going to substitute k inside. So -8 over k plus 3 power 3 equal to -8. Okay, so we just slightly do some arrangement. Okay, so since I have negative, so I can ignore it, and after that, I just bring it to the back, so I'll be able to get x plus 3 to the power of 3. So a power of 3 moving there, it will become a cube root. Okay, then after that, k plus 3. So after I solve it, then I'll be able to get like k plus 3 equal to 2 because the cube root of 8 is 2, right? Then after that, k equal to 1. Okay, so from that, then I'll be able to get my answer for k. I'm sorry, it should be -1. Yeah, 2 minus 3. Okay, so for this question, you are getting 1 mark for here. Then the second mark when you're trying to equate them in an equation. So 2 marks question. Yeah, so you kind of realize that how come it's like so long. So the idea is that if you are familiar with it, right? So after you write this, basically you do not need to make like a separate steps over here, which you can straight away like divide x equals to -1. Then after that, you do your differentiation while you are trying to equate the situation together. Yeah, but I'm just to do it like step by step so you can understand it better. Okay, so after that, let's move on to B. So given that the rate of the change of a y coordinate of p decreases at 16 unit per second. Okay, so which means that the rate of change for the y coordinate of p, how do we express this in a mathematical term? Okay, so remember the words rate of change, meaning that we are trying to talk about like how y is going to change when like time is changed. So that's why we're trying to express it in the term of dy over dt. Okay, it will be equal to, so the word decreases tell us that the rate of change is going to be negative. Okay, so it's given dy dt equals to negative 16. So find the rate of change of the coordinate, find the rate of change of the x coordinate at point P. So that's why the questions want you to find the dx dt for the point P. Okay, so since that the rate of change all occurs at P, so that's why if we want to relate these two together, then we must need to have like one common derivative that contains of y and x. So in this case, it will be easy that we just get what we have in A. So which means the dy dx for at point P is actually negative 1, right? So dy dx, which is the gradient for the tangent. So yeah, like what you can see, so dy dx equals to negative 1 when x equals to k, right? So that's why we use the same thing here. When x equals to k, it actually represents the point P. So that's why at point P, the dy dx is negative 1. So we want to find the rate of change of x coordinate dx dt. So one thing that it will be helpful for us to do is to try to arrange them in an equation first. So we can start with dy dx. Then after that, an easier way to do that normally I teach my students is that what you can try to do is you try to split it into two fraction. Then after that, for the first fraction, right, the numerator part, you are just going to copy exactly the same. Then after that, for the second fraction, you are going to write down the denominator. So which means you split like dy for the first part, then dx. Then after that, when you check on the questions, right, obviously you will have another variable that you didn't use yet, which is the dt. So for the empty space, you are going to put down dt. So the idea is that you see when we are trying to do like multiplication, right? So as long as we have like a denominator and a numerator, which is like the common factor, then what we are trying to do is we can factorize it, like can say it become like negative 1 and 1. So after that, when we multiply, then you get back to dy dx. So that's the idea. Okay. So after that, just by using the information that we have, then after that we try to find our dx dt. So since we know that dy dx is negative 1, so we are just going to substitute. So dy dt is negative 16. So now I have my dt dx. So don't worry, you will see that we want to find dx dt, but what happened here is dt dx. But after that, we're just going to do the reciprocal of it. So dt dx, then after that equal to, so negative 1 divided by negative 16, it will give you 1 over 16. So for now, we need dx dt, right? So we just do the reciprocal. Reciprocal meaning that you are just doing 1 over the answer, which in another words, if you have like fraction, then you can just try to flip it around lah, meaning like upside down. So from here, you are getting 16 over 1, which will give you the answer 16. Okay, so I mean, depends on you whether you want to write down the unit or not. I guess it's totally fine if you didn't, so you can just put down your answer. So for this question, it's very important for you to note that you should put a negative 16 here, because if not, then your answer will be a negative 1, which is wrong already. Okay, so from here, you will get 1 mark from substituting the number inside here. Then after that, your last answer. So 2 marks. Okay, all right, so let's move on to number 4. All right, number 4. So given that the function f of x equals to pqx plus 1 to the power of r, and the gradient function is given this, then after that, if the integral for f prime x is going to be the expression of this. So find the value of q and pqr are constant. Okay, so we can try to copy down the information which is given by the question first. So we have our f of x. Okay, then after that, it's given that the gradient function for f of x. So gradient function, which means that it's the dy dx. So since it's given like f of x instead of like y, so that's why we try to use like f prime x. Okay, so f prime x will be equal to 24 over qx plus 1 to the power of 2. Okay, so now if after you integrate the differential equation here. So after you integrate the gradient function, you get back to this. So find the value of q. So you can imagine that this is the original function, right? So after you differentiate, this is what you get. Then after that, you can imagine that what happened to here is you integrate the differentiate the derivative form. So which means from here to here. So after you integrate, you will get back to the original equation. So this is how it's that work. So that's why when you try to compare it, so meaning that from the information for the second sentence here, is given that the f of x is actually equal to 4 qx plus 1 to the power of r. You get what I mean, right? Because after you integrate the derivative form, you should get back the original equation. So that's why this is supposed to be the same with the original equation. So that's why we can start to do comparison here. So after you have done the comparison, so sorry, by comparison, and you'll be able to see that qx plus 1 to the power of r, so this part is the same, so which means p should be the same with 4. So that's why we have the first value, which is p is equal to 4. Okay, so after that, since we know that this is the derivative form after you differentiate the f of x, right? So what we can try to do is we try to find the f prime x by using the original function. Then after that, we try to compare. Okay, so meaning that I have f of x equal to p qx plus 1 to the power of r. So imagine if now I try to do my differentiation, so I'll be multiplying r in front. Okay, then after that, copy whatever inside the bracket. This is like the composite function as well. So the power minus 1, then after that, don't forget, differentiate and multiply whatever. So you need to differentiate whatever that is inside your bracket, then after that, it's going to be multiplied. So qx plus 1, after you differentiate, you get q. Okay, so we try to arrange it in a nicer way. So we have PQR, then after that QX plus 1 to the power of R minus 1. Okay, since it's given this form, so that's why it will be easier for us to actually change it to like a composite function. So we can do the comparison in a clearer way. So I have 24, then after that qx plus 1 to the power of negative r. Sorry, negative 2. Okay, so now I can start to do my second comparison. So it's the same thing by comparison. Okay, so now I'm comparing. Yeah, maybe let me just write down. This is my first equation. This is my second equation. So this is by the comparison for the first and the second. Okay, then after that, this is my like third equation here. Yeah, so this is my fourth. So which mean by comparison for the third and the fourth function, so I'll be able to see that you see qx plus 1 inside the bracket and qx plus 1 inside the bracket, which means that I can easily solve r first. So r minus 1 should be equal to negative 2. So from here, I'll be able to get my r, which is equal to negative 2 plus 1, which will give me negative 1. So after that, the PQR is going to be the same with 24, right? So PQR equals to 24. So now I can substitute the number that I have found just now. So for Q, then R negative 1 equals to 24. So move them around, then I'll be able to get Q equal to negative 6. Okay, so for this question, either you are getting P or R, you are given like 1 mark. Then after that, your last answer should be given 1 mark. So 2 marks here. Okay, all right. So let's try to see number 5. Okay, number 5. So this is a diagram that's showing you the nose cone of a rocket in a parabolic shape. Okay, so this is like the parabolic shape, and it's given that the function of this shape is y equals to ax squared plus 5, and the base meter is given here is like 3 meter. Okay, so the question is asking you to find the value of a, which is the a here, and to find the volume in a part B. Okay, I'm trying to split it in this way so that we can look at it like in an easier, in a much more organized way. Okay, so let's start with number 1 first. Yeah, so actually this is like considered a higher thinking order question, I would say. So which means that it's actually given you a situation that after that you actually need to think of a mathematical approach which you think that is suitable to be applied here or like to model here so that to help you to get whatever that you want. Okay, so I'm just going to transfer the information here in like this graph. So you can see that it's given is a function of the parabolic shape. So if you can recall in the Form 4 Chapter 3 quadratic function, when you learn how to draw a graph, right, we have like quadratic like this one and this one. So normally we call it like as a curve, or sometimes they'll say this is like a smiley graph, then after that the set face and so on. So but in a much more proper way, actually it's called as a parabola. Okay, is a shape like a quadratic graph is a parabola. So parabola is like a curve with a maximum or minimum point. Okay, so normally we don't say like a curve because like a cubic one can be a curve as well, or even like a reciprocal graph is a curve as well. Okay, so this is like it's called as parabola. So we can see that this is a quadratic. So now let me try to redraw the whole thing in like a 2D shape, then you will have a better idea. Then of course the drawing is not required in this question, but I'm just going to do it so that you can get a better understanding when I try to go further later. Okay, so yeah, I'm sorry my drawing here, but it's going to be like symmetrical about the y-axis here. Okay, so it's given that this function is y equal to ax squared plus 5. So either you know how to read it, then you should know that the y-intercept is at 5, or the other way is when you substitute 0 for the x, and you should be able to get y equals to 5. So which will give you that the intercept at this point is going to be 5. Okay, then obviously this is the origin. So since it's given that here the diameter is 3 meter, right? So you can try to imagine in such a way that when if let's say from this point to this point is going to be 3, so how long is this and how long is this, and how can I get the coordinate? So because there are two equal parts, okay, so that's why it's going to be 3 divided by 2, and I'll be able to get like negative 3 over 2 here and 3 over 2 here. Okay, I hope that is clear enough. Yeah, so it's like negative 1.5 to 1.5, and from negative 1 to 5 to 1.5 will give you like the 3 meter lah. Okay, so after that, what should we do next? Yeah, so by looking at this function, right, so now we need to find the a. So obviously from this graph, which is like this shape, then you know that the a should be a number that is a negative number. But how can you find the number accurately? So we need to check on where's the point that we have. Then eventually you cannot use 0.5 because when you substitute x as 0, then you eliminate the a, then you cannot find the a. But from the distance just now, we are able to get the negative 3 over 2 and 3 over 2, right? So you can use either the point negative 3 over 2, 0, or you use the point of 3 over 2, 0, they will actually give you the same answer. So what we try to do is we substitute into the function. Yeah, because it's a point on the curve, so it should be a point that satisfies this function. So you just substitute the x and y. So 0, let's use the positive one, then it will be easier. But yeah, eventually after you square it, then you'll get the same thing. So 3 over 2 squared, then plus 5. Okay, so from here, then you'll get 0 equal to 9 over 4a plus 5. Alright, so you just move it. So 9 over 4a equal to negative 5. Alright, so from here, then you just continue your calculation and you'll be able to get A equal to negative 20 over 9. Yeah. Alright, so this proves that our assumption just now is correct, which in this shape, your A should be a negative number. So in case if you get a negative, if you get a positive number, right, then you know that it should be something wrong there already. Okay, so for this question, it's going to be 2 mark. Yeah, the 4 mark is for the full question. So for this one, you will have 1 mark if you notice that that is point, that's coordinate that you can use here, which is uh by able to identify 3 over 2 0 or negative 3 over 2 0, then substitute into the equation, then you will get 1 mark. Then after that, your last answer 1 mark, so 2 marks here. Okay. Alright, so let's move on to the B part. Okay, so the B part is going to be like slightly long, yeah, but no worry. Okay, so let's try to see this. So the question one to find the volume of this cone. Okay, so you can see this is a cone, right? So if let's say I want to find this volume, then you should be able to relate this with your Form 5 chapter 2, which is integration. Yeah, so by having this curve, and if this is the volume that I want to find, then you can imagine that is this 2D shape, is this parabola going to revolve 360 about the y-axis. So you can imagine that how this thing works is like, for example, here. So after I revolve, right, then I'll be able to get to the other place. Then after that, I come back like over here, like 360. Then this is how I get the shape of like the cone here. Okay, so for this, then you can see that it's revolve about the y-axis, it's rotate about the y-axis. So that's why we will try to use the formula. Volume will be equal to pi, then after that x squared dy. Okay, if you can recall, because this is revolve about the y-axis, so you will use dy. Then after that, if you use dy, which means that in your function it should be x squared lah. Okay, so since it's given our function in terms of y, so which means that you need to find the x squared by yourself then in terms of y. So which means we try to arrange, do some arrangement here. So y equal to, just now we have our a, so 20 over 9 x squared plus 5. So since we want the x squared as the subject, so which means that we'll try to move it around. So I will have x squared equal to, so imagine I move the I move the 5, then negative 5, then after that, this one will become divide, right? So which means negative 9 over 20. Okay, yeah, so basically it's like minus, then after that divide lah. So divide, which means that I put the fraction like upside down. All right, so after that, then I can continue my integration here. So the volume will be equal to pi, and don't forget your limit. So this is like dy, so which means that you are looking at the y coordinate here, which is like from 0 to 5. Okay, so 0 to 5, then after that we put in our x squared, which is negative 9 over 20, and y minus 5. Yeah, you might have a questions like, why don't we try to multiply it, like expand it? You can do so. So you're just going to get the same thing now, but because of we have like the one of the identity or like the formula that tells that if let's say you have a constant for the integral, then you can like move it outside, right? Like for example, if let's say you have like ky to the power of dy, like with respect to dy, then after that you can like put the constant outside. Yeah, so this is what I'm going to do so that we do not need to deal with like this so-called like complicated fraction here. Okay, so I'm just going to put the constant outside. So negative 9 over 20. Okay, so now with this, then I can start my integration. Okay, yeah, so instead of like expanding it, then you can see that now it's become like easier. And don't forget your pi, sorry. Okay, so negative 9 over 20 pi. So after you integrate, then you'll be able to get y squared over 2, then minus 5y. All right, then you're going to substitute 0 to 5. Okay, so let us expand it, like substitute the number. So substitute 5 first. So I have 5 squared over 2 minus 5 times 5. So you can imagine that if let's say I substitute the 0 here, what do I get? So 0 divided by 2, then 5 multiplied by 0, then I'll get 0, right? So you can just do it like this. But just make sure that every time when you do this, then you are meaning that you're pretty sure that it's going to be 0 lah. Okay, so negative 9 over 20 pi. So which means here you can just try to get your answer by doing some calculation, and you'll be able to get negative 25 over 2. So your last answer should be equal to 45. Yeah, let me try to move a little bit. Yeah, so 45 over 8 pi. Okay, so you can be like a bit, sorry, go back to these questions. I think it's in meter. Yeah, so that's why it's m cube. So there's something that you can be a bit aware here is that every time when you try to do volume, right, you will not get a negative answer. So if let's say after you do your integration, after you substitute, then your answer happen to be a negative one, then perhaps you want to check back whether there's something wrong in your calculation or not. Okay, so yeah, that's the idea of it. But no worry about the unit. Yeah, you can actually just leave it blank for your like MX paper and so on, and you wouldn't be like punished by not writing your unit. Yeah, but eventually if you didn't write it correctly, then maybe you will get like your mark deducted there. Okay, so yeah, so meaning that after you have successfully got your integral, so which means from here then you will be able to get 1 mark and 1 mark, so it's like a 2 mark here. Okay, yeah, so that's it for number 5.